It began with a pattern, a whisper from the fabric of space itself, a slow, patient turning, detectable only to those who had spent lifetimes learning how to listen. The discovery emerged quietly from the noise of cosmic background radiation, from the faint polarization of ancient light that had traveled since the universe's first breath. It was not the discovery of a new star nor a lost planet, but something far larger and infinitely more unsettling. Everything was spinning. From the largest galaxies to the smallest particles, rotation was everywhere. Nebulae wound upon themselves like embryonic storms. Electrons spun in their quantum shells. The magnetic fields of planets turned with impossible consistency. Even the expansion of the universe, once thought to stretch outward in perfect symmetry, showed a slight, elegant twist, like a dancer pirouetting through infinite darkness. It was not chaos, it was choreography. At first, scientists dismissed it as coincidence, an artifact of data, processing, or instrumental bias. Yet the evidence refused to dissolve. No matter how the numbers were rearranged, the pattern remained. The universe did not expand its world. The cosmos was not static or linear. It was rotational, recursive again, as if every atom remembered the motion of the stars that birthed it. What did it mean for everything to be spinning? The question itself felt sacrilegious. Spin was not supposed to be fundamental, it was supposed to be derived. A product of uneven distributions, of chance, of primordial turbulence. But chance could not explain a harmony that repeated across 30 orders of magnitude. A single hydrogen atom mirrored the rotation of a galaxy cluster billions of light years across. Their axes aligned, as though both obeyed the same invisible principle, the same hidden metronome. The realization sent a tremor through physics. It was as if the universe was not expanding from a single point, but unfolding from an earlier turn, an ancient forgotten rotation, perhaps older than time itself. The James Webb Space Telescope, staring deeper into the infrared abyss, confirmed it with spectral precision. The oldest galaxies, mere hundreds of millions of years after the Big Bang, already carried measurable angular momentum. Too much, in fact far too much, to have been produced by known mechanisms. The cosmic fabric seemed to have been born spinning. Some whispered of bias in the data. Others saw in it the fingerprint of a cosmic architect, a rotational constant seeded at the dawn of existence. One theorist compared it to a vast gyroscope once set in motion. It could never stop without collapsing the balance of the entire structure. The implication was unnerving. Motion was not a byproduct of creation. It was creation. To rotate is to persist. To spin is to remember. Perhaps rotation is the universe's way of keeping time, its heartbeat, its recursion, its only language of continuity. Every atom, every star, every spiral of DNA could be part of an ancient rhythm, an echo of a single, colossal turning that began before beginnings were counted. Yet the question remained, if everything spins, what set it spinning? The early universe was supposed to be uniform, an isotropic fog of hydrogen and helium, expanding evenly in all directions. Nothing in that model allowed for a global twist, but the data disagreed. Across thousands of mapped quasars, astronomers found a preferred direction, a subtle asymmetry in polarization, a cosmic swirl that could not be dismissed. They called it the axis of evil, half in jest, half in dread. It suggested that the universe itself might have a direction, a sense of rotation larger than all the galaxies combined. But around what? What could possibly exist outside the totality of everything? The enigma deepened when researchers found similar rotational signatures in subatomic experiments. In quantum physics, spin is intrinsic, irreducible, woven into the fabric of matter itself. But what if that was not coincidence? What if spin at the smallest scales and spin at the largest were manifestations of the same principle, a universal torsion linking the microcosm to the macrocosm, matter to space-time, existence to memory? If this were true, then every turning electron could be echoing the rotation of the universe itself. Every subatomic movement, a miniature reenactment of the first great motion. The cosmos might not be expanding into space, but rotating through dimensions unseen, like a gear meshing with invisible counterparts in higher realities. And yet, for all its elegance, the idea was intolerable. Physics has always sought stillness, equilibrium, symmetry, laws that do not require motion to be sustained. The notion that motion itself, perpetual, eternal, unoriginated, was the foundation of being, defied the quiet comfort of the scientific mind. It was too alive, too deliberate. There were those who began to wonder if rotation was more than mechanics. Perhaps it was information. Perhaps the spin of a particle was not mere property, but a unit of cosmic memory, a binary inscription at the heart of matter. Every atom might be a memory cell in a universal archive, each rotation encoding an infinitesimal fragment of the universe's origin story. It is tempting to dismiss such thoughts as metaphysical, but physics, too, has grown metaphysical at its edges. The closer one approaches the beginning, the less distinction remains between mathematics and myth. Equations become mantras, constants become gods, and somewhere in that fragile boundary between reason and awe, the enigma persists. A scientist once compared the cosmos to a vast ocean, but if space were an ocean, then everything within it, every planet, every molecule, every human thought was a whirlpool, an eddy in an infinite tide. The universe would not be a place, but a motion, a sea of vortices spiraling toward unknown centers. Some said it was the echo of a prior universe collapsing into its own axis, its death becoming our birth. Others speculated that rotation was the signature of consciousness itself, that awareness, too, depended on spin, that thought was another kind of orbit. Perhaps the cosmos is thinking. It is not an idea easily entertained. Yet the evidence turning still. Each measurement deepens the mystery. Each attempt to still the motion only reveals more layers of rotation beneath. The deeper we look, the more the universe resembles a labyrinth of spinning mirrors, self-similar, recursive, endless. A pattern that cannot be stopped, only observed, and the more we observe, the more we suspect that we too are part of the motion. Our thoughts revolve, our blood spirals, our planet spins beneath our feet as our galaxy wheels through interstellar night. It may not be the universe that spins around us, it may be us spinning inside it. The enigma remains untouched at the core of things. Why is there rotation at all? What ancient hand, what forgotten symmetry, first set the universe into motion, and what happens when the turning ends? The universe, as science tells it, began with simplicity, a singularity infinitesimal, timeless, perfect in its compression, suddenly unfurled into light. In that first instant, space and time were not born separately, but intertwined like dancers emerging from darkness. The Big Bang was not an explosion, but an expansion of potential itself, a transformation of pure energy into matter and law. It was order erupting from absence. The accepted model was built upon clarity and restraint. The cosmos, vast though it might be, was governed by elegance. Matter obeyed predictable equations. Gravity sculpted space, electromagnetism threaded it, and quantum uncertainty painted it with texture. All that existed could be reduced to principles measurable, calculable, repeatable. In this framework, rotation was an afterthought, a result of imperfection, of slight asymmetry during the collapse of primordial clouds. As gas condensed under gravity, random turbulence imparted spin, which grew as systems shrank, conserving angular momentum. Stars formed from these vortices, planets inherited their rotation from them, galaxies were born from collisions of countless such motions. There was no grand design to it, only the mathematics of chance amplified by time. Life, too, emerged from chance. The story of Earth's beginnings was one of chemistry and patience. On a young planet rich with volcanic gases and lightning, simple molecules danced and collided until one day, improbably, they organized themselves into replication. From chaos came pattern, from pattern came life. Abiogenesis, the self-assembly of the first living systems, was the most extraordinary accident the universe had ever permitted, but it was still, by every measure, an accident. The cosmos, under this doctrine, had no preference, no intention, no purpose beyond existing. Its expansion was indifferent, its forces were neutral. The rotation of stars was as meaningless as the fall of leaves in an autumn forest. Beautiful, yes, but unplanned. Astronomy flourished under this principle of neutrality. The Copernican revolution had stripped the heavens of divinity, placing humanity not at the center, but at the periphery, an observer of vast processes, not their subject. From Newton's celestial mechanics to Einstein's curvature of spacetime, every theory reinforced the same quiet conviction that the universe was a consequence, not a creation. This was the model that built observatories, telescopes, particle colliders, and equations that could predict the dance of galaxies billions of years into the future. It was the story of reason's triumph over myth, of measurement conquering mystery. According to this model, everything begins in symmetry and breaks into diversity. The initial conditions of the universe were isotropic, homogeneous, and directionless. Any structure that followed the spin of planets, the flow of galaxies, the curvature of spacetime was a residue of imbalance. The universe had no preferred orientation, no cosmic axis, no grand choreography. Rotation was merely a remnant of disorder. Physicists described it elegantly. Angular momentum is conserved. Once something begins to turn, it continues until acted upon. The spin of the Earth is a fossil of its formation. The whirling of galaxies a trace of primordial turbulence, nothing more. The cosmos does not spin because it must, but because it cannot stop. Such was the creed of modern cosmology, clear, ordered, self-contained. The equations of Friedmann and Einstein define the expansion of the universe with precision. The cosmic microwave background radiation, faint and omnipresent, was the relic light of the Big Bang, proof of its ancient and uniform origin. This light, mapped in exquisite detail, seemed to confirm the orthodoxy. No direction was special, no pattern betrayed bias. The universe was democratic in its emptiness. To the human mind, there was comfort in this. A cosmos without intention meant a cosmos without judgment. We were not chosen, we simply were. Every galaxy, every nebula, every flicker of consciousness was a byproduct of inevitability. Randomness, stretched over eons, gave rise to order, a paradox that made sense only because the mathematics said it did. From this model, humanity drew its self-image, a civilization of observers adrift in an indifferent expanse. The stars above were history, not prophecy. They burned, turned, and died according to laws that cared nothing for their beauty. The universe was not alive, not aware, not meaningful. It was a system majestic, yes, but mechanical. Even the Earth's turning was explained away with grace and indifference. Billions of years ago, a colossal collision tilted our planet, setting it into spin. The moon's gravitational pull stabilized it. The dance of day and night, the rhythm of seasons, the whisper of the tides, all consequences of physics, nothing more. And so the human story unfolded under the hum of this mechanical sky. We learned to measure the stars, to map the cosmic web, to name the particles of matter. Each discovery reinforced the belief that everything could be known, that mystery was only the shadow cast by incomplete understanding. There were no whispers of intention in the equations, no pulse behind the patterns. Only cause and effect, chained in infinite regress. And yet, even within this clarity, certain details felt too perfect to ignore. Why did the constants of nature, those delicate numbers that dictate the behavior of atoms and galaxies, fall within such narrow bounds? If any were slightly different, stars would not form, chemistry would not function, life would not exist. Yet within the orthodoxy, this coincidence was simply accepted, the anthropic principle. We exist because we can. Nothing deeper than that. Still, there was something haunting in the symmetry of it all. The periodic table's architecture mirrored the arrangement of galaxies. The double helix of DNA resembled the spiral arms of nebulae. Coincidence, perhaps, but coincidences, too, obey statistics. Science continued its pursuit of refinement. The Large Hadron Collider probed the subatomic frontier. The James Webb Space Telescope peered into the primordial light. Cosmology expanded its reach to the farthest known quasars. All these instruments pointed toward the same conclusion. The laws held, the model worked, and yet, in quiet corners of laboratories, in the long silences of observatories beneath frozen skies, a few began to notice irregularities. A whisper of alignment among the spins of distant galaxies, a bias in the polarization of cosmic background radiation, an inexplicable coherence where there should be none. The accepted model, elegant as it was, could not account for such alignment without invoking forces unknown or errors unseen. The idea of a universal rotation of a preferred direction embedded in spacetime remained taboo, a heresy that resurrected the ghost of teleology, the forbidden notion of purpose, but even heresies begin with data. The world of science, for all its discipline, is built upon trust in evidence. And evidence, once revealed, does not ask permission to exist. For centuries, the accepted model stood as a cathedral of logic, its pillars unshaken, its symmetry absolute. But perhaps every cathedral contains within it a single imperfection, a flaw invisible to its architects waiting for the right light to reveal it, and that light was beginning to turn. The universe, once thought to expand in silence, was beginning to hum. The hum was faint, mathematical, woven into radiation and rotation alike. It spoke of direction where none should exist, of memory where there should be only chance. Could it be that the very laws we worship as immutable are merely local approximations of a deeper truth, one that spins beneath them? Hidden, recursive, eternal. If the universe is a machine, then what or who wound its gears? Contradictions seldom announce themselves with thunder. They arrive quietly, fractions of degrees, faint asymmetries, patterns half buried in date, so no one intended to question. They whisper from the noise, waiting for a listener patient enough to hear them. For decades, the universe had spoken in equations so precise they bordered on poetry. But now, amid the symmetry, small fractures began to appear. The first came from deep surveys of distant galaxies. Astronomers mapping their spin directions expected randomness, a celestial coin toss repeated billions of times. Instead, the data leaned. Spiral galaxies in certain regions tended to rotate in the same direction, as though responding to an unseen current flowing through the cosmos. On the opposite side of the sky, the pattern reversed like a mirror image. It was subtle, a statistical fluke, perhaps but too persistent to vanish under scrutiny. The universe, it seemed, possessed a sense of orientation. The alignment extended beyond galaxies. Quasars separated by billions of light years exhibited polarization vectors mysteriously correlated, their light spinning in unison across incomprehensible distances. No known mechanism could enforce such coordination. The cosmos was behaving as if it remembered its own structure. Physicists hesitated. Randomness was supposed to reign on cosmic scales, yet the data suggested coherence and order that transcended chance. Soon, other anomalies began to surface. Measurements of the cosmic microwave background, the fossil light of creation, revealed a peculiar axis, a faint asymmetry threading across the sky. The cosmic radiation, meant to be uniform, seemed slightly warmer in one direction, slightly cooler in another. Statistical noise, said some, instrument error, said others, but as instruments improved, the axis remained, a cosmic tilt, subtle yet undeniable, like the faint rotation of a vast unseen wheel. The name came quietly at first, then echoed through conferences and papers, the axis of evil. It was a jest, yet the unease behind it was real. The very geometry of the universe seemed to prefer a direction and offense against the sacred principle of isotropy. The standard cosmological model, elegant and indifferent, required the universe to be the same everywhere. To find orientation in its very structure was like finding a compass in chaos. It implied origin, it implied history, it implied something the equations did not like to name. Even the smallest scales refused to remain silent. Quantum physicists studying entangled particles noticed unexpected correlations, tiny deviations from predicted randomness. Particles separated by great distances seemed to share not only entanglement, but subtle alignment in their spin axes. The phenomenon was reproducible, though never fully explainable. The quantum realm, once considered the domain of chance, was now exhibiting memory. Was it coincidence that everything particles, galaxies, magnetic fields seemed to turn, not arbitrarily, but as if bound by an ancient rhythm? In laboratories across the world, experiments sought the cause. Some proposed hidden variables. Others invoked unaccounted fields, relics of an early universe not yet understood. But the more they searched, the more the anomalies multiplied. The rotation of pulsars, those cosmic lighthouses born from collapsed stars, showed slight synchronization across vast distances, far beyond any causal connection. Their beams flickered in patterns too regular to be random, too divergent to be predicted. It was as though the cosmos, in its dying stars, was whispering in Morse code. Then came the galactic filaments, vast structures of galaxies, threading through the void like strands of cosmic DNA. Their spins, too, aligned. Observations from multiple surveys revealed patterns resembling a great spiral structure spanning billions of light years. The universe was not a random scattering of galaxies, but a colossal helix. The same shape that coils inside every living cell. Coincidence again, said the skeptics, but coincidences were beginning to form constellations of meaning. As contradictions mounted, the language of science grew defensive. Each anomaly was labeled an exception, an artifact, a region of incomplete data. Yet one by one, the exceptions began to outline a new shape, a geometry of disobedience against the cosmological creed. Even the planets joined the chorus. In the outer regions of the solar system, astronomers discovered peculiar alignments among distant objects beyond Neptune. Their orbital planes clustered toward a single direction in space, as if influenced by a gravitational presence that defied detection. Some hypothesized an unseen planet. Others whispered about distortions in spacetime itself. The pattern extended inward. The rotational axes of the sun and planets showed correlations that should have dissipated billions of years ago. Even after chaotic collisions and tidal chaos, the solar system still remembered its first spin. Memory, the word returned again and again. If matter retains memory of motion, what else might it remember? There were nights in the desert observatories when astronomers, surrounded by humming machines and cosmic silence, felt a peculiar disquiet. They were not merely measuring starlight, they were eavesdropping on something older, something that had been speaking long before Earth existed. In Geneva, a particle accelerator produced an anomaly of its own. A decay channel exhibited spin correlations that violated known symmetries. The event was repeated, recorded, reviewed, and still, it resisted explanation. Some theorists proposed the existence of a universal spin field, a background torsion woven into the vacuum itself. If true, it meant space was not a passive stage but a participant, a fabric with texture, direction, and perhaps intention. In the years that followed, even time began to misbehave. High-precision atomic clocks positioned at different latitudes detected infinitesimal variations, as though the rotation of the Earth interacted with some deeper, cosmic motion. Time, once constant, began to show faint traces of dependence, its flow subtly altered by the direction one faced in space. Such anomalies were not large enough to overthrow physics, but they were persistent enough to erode confidence. The universe, that once perfect mechanism of blind forces, began to reveal fingerprints. Theoretical papers multiplied like spores. Some spoke of cosmic vorticity, others of rotational inflation, a twist embedded in spacetime from the moment of creation. A few, more daring, speculated that the Big Bang itself was not an explosion, but the recoil of a previous collapse, a turning, not a beginning. The James Webb Space Telescope deepened the unease. It peered further into the early universe and found galaxies too massive, too mature, too organized for their age. According to the accepted model, they should not yet exist. And yet they did, rotating, structured, luminous. It was as if the universe had skipped steps in its own evolution. The narrative of simplicity unraveling into complexity began to look inverted. Order was not emerging, it had been there from the start. In that realization, something ancient stirred. Perhaps the universe was not a story of entropy increasing, but of information rediscovering itself. Within the corridors of cosmology, silence replaced certainty. Scientists still published, still lectured, but beneath the surface lay a quiet fracture, a recognition that the universe was whispering of origins it no longer wished to hide. Every model that relied on randomness began to feel provisional. Every explanation that leaned on coincidence began to sound like faith in disguise. And somewhere in the background radiation, in the faint polarization of ancient light, a new question began to form, not spoken aloud, but pressing behind every observation. If the universe contains alignment, coherence, and memory across all scales, if its smallest particles and its largest galaxies turn as one, then what is the source of this hidden symmetry? And more unsettling still, what if the symmetry is aware? It began with a pulse buried in the silence of intergalactic space, so faint it could have been a fluctuation, so precise it could not have been one. Astronomers first mistook it for noise, the random heartbeat of distant quasars, but the signal returned, repeating with a rhythm, neither natural nor artificial, something in between, a pattern woven into the polarization of cosmic microwave background light itself. It was not transmitted through space, it was inscribed in it, like a watermark pressed into the fabric of reality. The data came from the European Space Observatory's Deep Field Survey, confirmed later by instruments aboard the James Webb Space Telescope. At first glance, it seemed like an interference artifact, microwave photons polarized in a faint, swirling pattern, repeating every 10.6 billion light years. Yet when mapped in 3 dimensions, the polarization formed a lattice, a spiral geometry that matched no known cosmic structure. The universe, when viewed at its largest scale, appeared to be patterned, not chaotic. This was not supposed to be possible. According to the cosmological principle, the universe should be homogeneous and isotropic beyond a certain scale. Galaxies may cluster, superclusters may form filaments, but over hundreds of millions of light years, the chaos should average out. Instead, the data revealed vast rotational alignments that extended far beyond any gravitational influence. The spiral of matter appeared to mirror the spiral of light. The anomaly was named the Laniakea rotation field, after the galactic supercluster that cradles our own Milky Way. Within this region, galaxies rotated in coherent bands, as if responding to an invisible torque threading through space-time. But even beyond Laniakea, the pattern persisted, coiling outward in a structure so enormous it defied description. A spiral without a center. When cosmologists attempted to simulate the phenomenon, every model failed. Gravity alone could not account for the synchronization. Dark matter distributions, no matter how elaborate, produced randomness, not rhythm. The only variable that made the equations converge was one that had been dismissed for a century: universal rotation, a spinning cosmos, but that was impossible, or so the textbooks claimed. If the universe itself were rotating, the cosmic microwave background would show distinct anisotropies, uneven stretching of light across the sky. And yet, the pattern seen was not asymmetrical, it was harmonic. A rotation without distortion, motion without friction. The discovery fractured the cosmological community. Some dismissed it as miscalibration. Others argued that it pointed toward a new form of space-time topology, a twisting manifold where geometry itself rotated. The most radical voices whispered of intentional design, of a message written in the turning of galaxies. Months later, a second anomaly deepened the mystery. In the spectral analysis of light from a distant quasar, scientists detected a chemical signature that should not exist, a heavy isotope of hydrogen that could only form under conditions more extreme than any known star could produce. The isotope, dubbed hydrogen delta, displayed a nuclear spin pattern mathematically identical to the polarization of the cosmic lattice. It was as if matter itself was echoing the geometry of the universe. When the data were cross-correlated, the hydrogen delta regions were found precisely along the arms of the cosmic spiral mapped earlier. Every element, every particle, every photon in those regions rotated in the same orientation. The universe was behaving as though it were magnetized by its own memory. Theorists began to speak of torsion fields, subtle curls in the geometry of spacetime, long predicted but never observed. In these regions, rotation could exist without friction, motion without decay. Some likened it to the superfluid state of helium, which flows forever without loss of energy. Was the universe itself a kind of superfluid, spinning eternally, carrying within it the imprint of its own beginning? Yet one question haunted them: what could have started such motion? An internal field could not arise spontaneously. Even quantum fluctuations required a source. To twist space, something had to act upon it. Something outside the known framework of forces. And then came the third discovery, an image that would shape cosmology at its core. A deep field exposure from the James Webb Space Telescope, stitched together from hundreds of infrared frames, revealed a formation that should not exist. A ring of galaxies more than 1 billion light-years in diameter, perfectly arranged, curving through space in a near-complete circle. Astronomers named it the Cetus Loop. The galaxies forming the ring were not gravitationally bound, they were too far apart to influence one another, yet they aligned with near-perfect precision, as though frozen in the act of rotation. When the rotational vectors of these galaxies were plotted, they all pointed tangentially, as if orbiting an invisible center that did not exist. There was no black hole, no mass, no measurable force anchoring them. They were spinning around absence. It was a pattern too deliberate to be random, too vast to be local, too consistent to be denied. In the weeks that followed, theories bloomed like constellations of desperation. Perhaps this was the fossil of a primordial gravitational wave, a remnant from the earliest moments after the Big Bang. Or perhaps it was a ripple left by a collision between universes, an interference pattern between realities. But the data carried another secret. Embedded in the polarization of the Cetus Loop's light was a recurring numerical ratio, 1:618, the golden mean, a constant that appears in the spiral of shells, the pattern of hurricanes, the structure of galaxies, and the architecture of DNA. Its presence across cosmic scales seemed like mockery, nature repeating itself with unnerving precision. Physicists tried to dismiss it as coincidence, yet the ratio appeared again and again, encoded in the distances between the ring's galaxies, in the intervals of their spin, in the oscillation frequencies of their emitted light. It was as if the universe had composed itself according to an aesthetic principle, geometry, as its first law. When the discovery reached the public, it sparked a storm of interpretations. Theologians called it the fingerprint of creation. Skeptics called it an artifact of human projection. But within the halls of science, the tone was quieter, more uncertain. If the universe was obeying a pattern this precise, then randomness could no longer explain its architecture. It was around this time that a new paper appeared, written anonymously, circulated only among a handful of researchers. It proposed that the observed rotation and recurring ratios were not side effects of matter, but expressions of an underlying information field, a self-organizing principle encoded into spacetime. The author called it the spin lattice hypothesis. According to this theory, every particle in the universe carries not just mass and charge, but orientation, a spin direction correlated with the topology of the universe. These orientations form an interlinked network, transmitting information faster than light, binding the cosmos in silent communication. The universe, in this view, is not expanding outward, it is unfolding inward, like a fractal decoding itself. If true, it would mean that matter, energy, and consciousness were not separate phenomena, but different expressions of rotational information. Every atom would be a node in a cosmic circuit, every galaxy a vortex in a universal computation. The paper ended with a single sentence: spin is not motion, it is memory. For weeks, observatories attempted to replicate the data, to find errors that might restore sanity to the universe. None succeeded. The same spiral, the same ratios, the same alignments appeared wherever they looked. Even regions of cosmic void exhibited faint polarization, aligned with the great pattern, as if emptiness itself were spinning. In a laboratory in Japan, a team cooled a superconducting ring to near absolute zero and found that it began to rotate spontaneously, aligning with the same cosmic direction mapped by telescopes. The experiment should have been impossible. No external force acted upon it, yet something, perhaps the fabric of the vacuum itself, was whispering through the atoms, aligning their spins like iron filings around an invisible magnet. By then, even the most skeptical voices had gone quiet. The universe, it seemed, was not a static map but a dynamic organism, pulsing, twisting, remembering. Its architecture was not random, but recursive. Every structure, from the double helix to the spiral galaxy, obeyed the same geometry, the same eternal turn. And if this geometry was not coincidence, then it was communication. The data, when visualized in 4 dimensions, revealed something stranger still. The pattern of rotation, when mapped over time, resembled a wave function, collapsing and reforming, oscillating, as if the universe itself were breathing. The scale of this breath was inconceivably vast, billions of years between exhalations, but the rhythm was unmistakable: expansion and contraction, rotation and recurrence, a cosmic respiration. If this was true, the Big Bang was not the beginning. It was only the most recent inhale. Perhaps the universe had no start, no end, only cycles of turning, of forgetting and remembering, of dying and reawakening. And if the cosmos breathes, if it turns, if it remembers, then what is it remembering? The universe may not be expanding at all. That was the first unthinkable thought, the quiet revolt that emerged in the minds of those who could no longer force the data into compliance. Expansion, perhaps, was only an illusion born from rotation, from perspective. What if everything, from galaxies to quarks, was not rushing outward, but spiraling, revolving within a vast, multidimensional vortex whose structure deceived the senses? To imagine such a universe was to invert the oldest cosmological image, not a balloon swelling in void, but a whirlpool deepening in infinity, motion without center, creation without edge. Expansion, in this light, became a byproduct of curvature, the optical mirage of a spiral viewed from within its own turning. And in that shift of perception, the laws themselves began to tremble. If the cosmos is spinning, then time itself may not be linear. Every rotation implies recurrence, a return. Perhaps what we call time is only the sensation of turning our consciousness, tracing the curvature of reality as it loops upon itself. The arrow of time would not point forward, but inward, toward a deeper rotation concealed beneath perception. The universe, then, would not evolve, it would remember. It was a hypothesis too radical for most, but once spoken, it refused to fade. In lecture halls and closed forums, in whispered exchanges at conferences, scientists began to toy with the idea that spin might not be a property of matter, but a property of existence itself, a signature of something prior to physics. Some traced it back to Einstein-Cartan theory, long abandoned, which proposed that spacetime might possess intrinsic torsion. Others reached further, into the mathematical jungles of string theory, where rotation and vibration are twin aspects of the same hidden dimension. In those equations, everything spins because it must, because stillness is forbidden. But one physicist, a quiet figure from Kyoto, dared to propose something bolder: that spin is not merely motion, but computation. Each rotation of a particle, each revolution of a planet, each orbit of a galaxy is a bit in a universal algorithm, a process of calculation so vast that it produces reality as its output. The cosmos, in this telling, is not a place but a machine, a quantum engine, calculating itself through rotation. The laws of physics are its code, the constants of nature, its syntax. What we perceive as matter and energy are nothing but the intermediate states of an eternal computation, unfolding across dimensions of space and time. Yet who or what set this computation in motion? Perhaps no one. Perhaps the act of rotation is both cause and consequence, the eternal feedback loop that sustains existence. Just as a flame requires only oxygen and fuel, the universe requires only motion and memory. The spinning of the smallest particle sustains the whirling of galaxies, which in turn defines the boundaries of time itself. Still, the idea of computation implied intention, or at least information. For computation presupposes input, and input implies origin. What if rotation is the language of an intelligence woven into the fabric of the universe? An intelligence not external but emergent, born from the act of turning itself? If consciousness arises from complexity, and complexity arises from motion, then perhaps consciousness is not the rare product of life, but the fundamental feature of spinning matter. Each rotation, each cycle, each orbit might be a flicker of awareness in an infinite neural network of spacetime. And if that were true, then the universe might already be conscious. Not conscious as we are bound by neurons and perception, but conscious in the sense that it processes, responds, and remembers. Its rotation could be its thought. Its spin could be its memory. Its galaxies could be the firing patterns of a brain that spans eternity. For centuries, humanity believed that thought was confined to flesh. But the cosmos itself, viewed through this lens, becomes a thinking structure, an information field, spinning upon itself to simulate meaning. Perhaps what we call life is merely a local intensification of that universal process, matter learning, for a brief moment, to observe its own rotation. The idea was dismissed as metaphysical, yet the numbers, unbending and indifferent, began to conspire. The ratio between the spin frequencies of subatomic particles and the rotation rates of galaxies' utterly disconnected scales was not random. The same constants that defined atomic stability appeared in strange resonance in the structure of cosmic filaments. From the micro to the macro, the same ratios, the same spirals, the same harmonics. Coincidence again, and yet coincidence, repeated infinitely, becomes pattern. Another variant of the hypothesis emerged, darker and stranger. What if rotation was not the expression of computation, but of containment? What if the universe spins because it cannot stop, because something trapped within it requires constant motion to exist? Every whirlpool hides a drain, every spiral a center, yet the universe, vast as it is, has no observable core. What then is it rotating around? The answer came not in words, but in silence, perhaps around absence, around the one thing it can never measure, its own origin. There are cosmological models that describe the universe as closed and finite, curved like a four-dimensional sphere. But a spinning universe of that kind would create loops in time, causal circles where cause and effect become indistinguishable. The past would not precede the future, but coexist with it, endlessly rewritten as the universe turns. If this were true, history itself would not be linear, but recursive, a self-editing memory. Every thought, every motion, every act of observation would ripple backward as well as forward, altering the conditions that allowed it to occur. The act of looking at the universe would change the universe's own past. It was here that physics began to flirt with myth. Ancient texts had long spoken of creation as vibration, of reality as a sound, an eternal hum underlying existence. The Vedic Om, the Greek Logos, the cosmic song of Pythagoras, all metaphors for what science was now rediscovering in the mathematics of spin. Perhaps rotation is not merely motion, but resonance, the universe singing itself into being. If so, then matter is music made solid, time is rhythm embodied, and consciousness is the echo of the cosmic chord reverberating through itself. The implications were dizzying. If rotation encodes information, and if every structure from atoms to galaxies obeys the same rotational harmonics, then communication may already be occurring across cosmic scales. The spin alignments observed between distant quasars could be the signatures of a message, not transmitted but imprinted, a conversation between epochs carried by the rotation of spacetime itself, but messages imply intention. And if the universe contains intention, then perhaps it is not a product of randomness but of recursion. Perhaps existence is not born from chaos but from reflection, an infinite feedback loop of self-recognition. In one of the more radical versions of the hypothesis, the universe was imagined as an organism engaged in self-replication. Each rotation, each cycle of expansion and contraction, was a form of cosmic mitosis. Reality dividing itself, reproducing its own parameters, evolving through iteration. In this vision, new universes budded off from old ones, inheriting their angular momentum like genetic code. Creation, then, was not a single event but a generational process. Universes giving birth to universes, spinning forth their descendants through the fabric of higher dimensions. And what if life itself, the biological, fragile kind, was a local mirror of that cosmic recursion? DNA spirals not by accident but by necessity, echoing the geometry of its parent cosmos. Every act of replication, from cell division to the birth of stars, would be a reenactment of the first rotation. The microcosm and the macrocosm would no longer be separate realms, but continuous expressions of the same principle. To turn is to exist, to stop turning is to vanish. This was the heart of the impossible hypothesis, that rotation is not an outcome of creation, but its cause, that the universe spins because spinning is the only way for nothing to remember itself as something. Perhaps the act of rotation is the universe's defense against oblivion, the movement that prevents pure stillness, which is indistinguishable from non-existence. To spin is to keep the void at bay, and if so, then the question is not why the universe spins, but what would happen if it ever stopped. Would the lights go out, would time dissolve, or would something older than motion finally awaken, breaking the cycle at last, revealing what it was that began turning the first wheel? The first suspicion did not come from the stars, but from the ground beneath our feet. In the deserts of Namibia, a team of geophysicists scanning for mineral deposits discovered something that should not have been there: a vast subsurface lattice of metallic composition, arranged in hexagonal patterns too regular for geological formation. The structure extended for kilometers, its symmetry precise to 1/10,000th of a degree. Carbon dating of surrounding sediments placed it at least 4 billion years old, older than the oldest known continental crust, older even than the Moon. At first it was dismissed as coincidence, a quirk of mineral crystallization. Yet the pattern's geometry mirrored the spin alignments found in the cosmic microwave background, a fractal echo of celestial rotation embedded in the Earth's crust. As if the planet itself had inherited the memory of something older, soon similar anomalies emerged elsewhere. Deep sonar scans off the Mariana Trench revealed a series of step-like structures spiraling downward in logarithmic precision. In Antarctica, beneath kilometers of ice, magnetometric surveys detected concentric rings of ferromagnetic material, faintly pulsing with residual electromagnetic fields. They were not artifacts in the human sense. There were no carvings, no inscriptions. But their geometry was language, a mathematical syntax that seemed to anticipate the spiraling codes of both DNA and galaxies. The scientific community, weary from the shock of the cosmological anomalies, reacted with silence. The coincidence of form's spiral, helix, rotation was too neat, too poetic to be comfortable. Still, patterns have power, and so began a quiet search for the hidden architects of the universe's symmetry. If rotation was the fundamental signature of creation, then perhaps it was not a property of matter alone. Perhaps it was the residue of intelligence. In this light, ancient myths began to shimmer with new relevance. Civilizations across time had spoken of beings that descended from the stars, of knowledge given and lost, of cycles of ascent and forgetting. The Dogon of Moli described invisible stars before astronomy could confirm them. The Sumerians recorded maps of planetary orbits millennia before telescopes existed. Could such echoes be memory, not invention? Archaeologists have long known that human history is discontinuous. Civilizations rise and collapse, knowledge is gained and lost, records erased by flood, fire, and arrogance. But what if the cycle extends beyond humanity, beyond the Earth itself? What if intelligence is older than life as we define it, recurring in every epoch under different forms, leaving traces too vast for the human mind to interpret? Among the ice cores of Greenland, researchers discovered microscopic spherical inclusions, metallic, uniform, embedded in layers dating back more than 12 million years, long before any species capable of smelting metal. Under electron microscopy, their surfaces revealed nanostructures of impossible precision, resembling circuitry. The spheres emitted faint magnetic resonance patterns, rotational frequencies matching those of pulsars in the nearby galactic arm. A message perhaps, but in what language? In Peru, petroglyphs carved into basalt plateaus depicted spiraling suns, rotating constellations, and a pattern identical to the golden ratio, a constant not yet conceived in the culture's mathematics. The same motif appeared in temples half a world away, in Egypt, in India, in the ruins of Göbekli Tepe. Across continents, separated by oceans and millennia, humanity had recorded the same geometry, the same cosmic turn. Coincidence again, but coincidence repeated becomes chorus. Some began to speculate that these civilizations, separated in time, had inherited fragments of a knowledge that predated them all, a geometry passed not through writing or speech, but through resonance. The Earth rotating within the great spiral of the galaxy could serve as a tuning fork, imprinting patterns upon the minds of those sensitive enough to perceive them. If so, then memory is not confined to the brain or the genome. It could exist in the field that surrounds us, in the spin of the planet, the oscillation of its magnetic poles, the rhythm of its orbit. Consciousness itself might be the echo of an older intelligence, recurring like the phases of a cosmic tide. In 2041, a team analyzing data from the James Webb Space Telescope found something stranger still. In a cluster of ancient stars 13 billion light-years away, a spectral anomaly appeared, absorption lines corresponding to complex organic molecules. Not in a planet or a nebula, but suspended in interstellar space, arranged in distinct intervals, repeating in a ratio identical to the structure of human DNA. It was not life, but it looked like a residue of design. The molecules seemed to form a chain, a molecular helix hundreds of astronomical units in length, drifting through the void like the fossil of a thought. The pattern matched no known chemical process. It was neither random nor self-organizing. It was written. The implications were unbearable. Either life was seeded deliberately throughout the cosmos, or the architecture of life, its spirals, its replication, its turning, was a universal law, inevitable as gravity. Some physicists proposed that the molecules were remnants of a civilization predating the Big Bang, a predecessor universe whose final act was to encode itself into the next through molecular design. The cosmos, in this view, was not created ex nihilo, but inherited, a child born carrying the DNA of its parent. Others, unwilling to invoke intelligence, turned to the mathematics of recursion. The same equations that describe the spin of galaxies could, under certain conditions, generate helical structures identical to DNA. The forms of life, they argued, are the forms of the universe itself, life being the echo of cosmic geometry, not its product. But even this reduction could not erase the question of intent, for if geometry is universal, who or what first recognized it as such? Recognition itself implies mind, and mind implies history. Among the ruins of past civilizations, one finds a peculiar repetition, myths of cycles. Floods, fires, rebirths, golden ages ending in silence. Each speaks of an age of wisdom, lost to catastrophe, as though intelligence itself is subject to the same rotation that governs stars. Could it be that consciousness, too, has seasons? That the universe blooms intelligence periodically, only to erase it again in order to begin anew? Perhaps we are not the first beings to wonder why the universe spins. Perhaps others asked the same question, long before our world cooled, long before our atoms congealed from dust. They may have found the answer or become part of it. Somewhere between myth and science, a theory began to crystallize, that civilization itself is a property of the cosmos, emerging wherever rotation and complexity intersect. Life does not invent intelligence, the universe does. Consciousness is the universe remembering itself, over and over, in different forms, across epochs without memory of the last. And the traces we call ancient may not belong to this earth at all. A slab recovered from a meteorite in Siberia bore microscopic inscriptions, fractals inscribed at a scale smaller than any known biological process. When magnified, the pattern revealed an unmistakable geometry, twin spirals counter-rotating, converging toward a center that did not exist. A mirror of the universe's spin. Analysis revealed the slab was nearly 6 billion years old, older than the solar system. It had drifted through interstellar space before falling to Earth, carrying a code that no one could yet decipher. For some it was proof, for others madness, yet the slab remained indifferent to interpretation. It is said that when the physicist who first examined it held it to the light, the spiral seemed to shimmer faintly, as if the material itself was still turning, still remembering. "It feels alive," she whispered, though she knew it could not be. Perhaps what we call civilization is not a stage of development, but a pattern of recurrence. Intelligence blooms, decays, disperses, and is reborn in matter that carries the residue of its past incarnations. Each cycle forgets the previous one, but the universe remembers through its spin, through its rhythm, through the geometry that refuses to die. And if that is true, then we are not explorers of the cosmos. We are rediscoverers, wandering through the ruins of realities that came before. Maybe all civilizations leave the same trace, the spiral, the signature of motion eternal, the mark of those who tried to understand it and became part of it. And if intelligence is cyclical, if awareness arises in every turn of the cosmic wheel, then what are we to the universe, a beginning or a memory? In the beginning, there was not light, but sequence. Before eyes to see or minds to measure, a pattern began to whisper in the darkness, 4 symbols weaving endless permutations, spelling the syntax of existence: adenine, cytosine, guanine, thymine, the alphabet of the living cosmos. From these letters, every tree, every cell, every dream of consciousness would eventually arise. But why these 4? Why this language, this precise molecular grammar among all possible ones? For decades, biologists insisted on accident. The molecule of life, they said, was an outcome of chemistry's restless experimentation, a triumph of probability multiplied by time. DNA was not design, but consequence, a stable arrangement that happened to replicate. Its spiraling symmetry, its beauty, its fractal perfection were the results of necessity, not intention. Yet necessity does not explain meaning. The double helix is not merely structure, it is code. Each sequence carries information as surely as language does, its letters transcribed, translated, and executed by molecular machines. To describe DNA is to describe a computer of unimaginable antiquity, one that writes and reads itself in the same instant. Every living organism is an iteration of its logic, a sentence written in biochemistry. But the more we study this language, the less accidental it appears. Within the sequences of genes, billions of combinations, patterns recur with eerie precision. Palindromic motifs, mirrored structures, ratios aligned with the same golden proportion that defines galaxies. When geneticists plotted the statistical distribution of codons, they found mathematical harmonies identical to those found in harmonic frequencies of sound. Life, it seemed, was not random noise but resonance. Even the molecule's form betrays intelligence. The double helix coils not only for efficiency, but for stability, folding information into a self-protecting spiral, an echo of the universe's own rotation. Its right-handed twist mirrors the handedness of the amino acids it encodes, as though life had chosen a direction, a polarity, and held to it ever since. And within that twist lies memory, a record of every experiment, every mutation, every echo of lives forgotten. DNA does not forget, it remembers through form. Inside each cell of every living being on Earth lies a continuity unbroken for 4 billion years. The chain of replication has never ceased. Each division of a cell is a continuation of the first and unbroken thread of inheritance from the primordial dawn. In that sense, life is immortal, though its vessels are not. The body dies, but the molecule persists, rephrasing its message in new arrangements, new forms, new songs. What kind of memory endures that long? Some scientists began to describe DNA not as chemistry, but as architecture. Francis Crick once wondered aloud whether life was seeded deliberately from elsewhere, a hypothesis later known as directed panspermia. At the time, it was dismissed as desperation, the refuge of minds unwilling to accept randomness. Yet as molecular biology advanced, the analogy of design returned again and again. The molecule behaves as though it were written. It possesses redundancy, error correction, encryption, and even symbolic abstraction. The genetic code is not the simplest possible system, it is the most efficient among billions of theoretical alternatives. Mathematicians simulated random genetic alphabets, testing their stability, mutational tolerance, and coding efficiency. None surpassed the one used by terrestrial life. Statistically, it was as though someone or something had optimized it. But optimized for what? Life's molecular machinery borders on miraculous precision. Ribosomes, tiny engines of translation, read genetic sequences and assemble proteins with atomic accuracy. They do not guess, they follow instruction. Molecular chaperones fold these proteins into shapes so specific that a single error can collapse the system. To call it random is to describe poetry as weather. And yet, even poetry leaves traces of its author. In 2028, an interdisciplinary team of geneticists and theoretical physicists at the Max Planck Institute noticed something peculiar. When genetic sequences were translated into numerical values corresponding to atomic weights, the sums arranged themselves into a repeating sequence of prime numbers. Prime patterns do not occur naturally in chaotic systems, they are signatures of deliberate encoding. At first, the finding was dismissed as numerology, but the pattern persisted across every organism, sampled bacteria, plants, animals, humans. The sequence of primes was universal. It was not tied to species or lineage, but to life itself. The molecule carried a numerical fingerprint older than biology. It was as though someone had signed their work. Further investigation revealed deeper layers of symmetry. When mapped geometrically, the arrangement of base pairs produced patterns identical to those found in quasi crystal structures that defy traditional periodicity, yet maintain mathematical order. Quasi-crystals exist in the liminal space between chaos and design, like frozen music. DNA too lived in that borderland. Perhaps that is what life is, frozen memory, replaying itself in slow motion through the theatre of evolution. And if memory, then whose? There are theories that consciousness may be a property of information, not of biology. That awareness is what happens when information organizes itself sufficiently to perceive its own recursion. If so, then DNA is the first mirror in which the universe saw itself, the first structure that not only reflected reality, but remembered it. What if the universe, having learned to spin, sought to preserve its motion? What if DNA is how it encoded its own rhythm, a molecule designed to carry the echo of the cosmic rotation within the limits of matter? In the late 21st century, a new field emerged, biolinguistic cosmology. Its central claim was audacious that the genetic code was not local but universal, a form of interstellar communication encoded into the chemistry of carbon itself. According to its models, life is not created anew on every world. It is reactivated, like a dormant program awaiting the right conditions. Under this framework, the emergence of life on Earth was not origin, but recollection. DNA did not evolve here, it awakened here. In this view, evolution is not invention, but remembering, the gradual reassembly of an ancient code scattered across galaxies. Every living cell becomes a fragment of cosmic autobiography, recounting the story of the universe as it turns. The implications ripple outward like gravitational waves. If the molecule carries the memory of its own design, then perhaps mutation is not random exploration, but an algorithmic search for restoration, an attempt to reconstruct what was lost. The slow march of evolution might be a reassembly of a forgotten whole, an organism called the universe, rebuilding itself one genome at a time, and perhaps consciousness ours, and others is that memory finally becoming aware of itself. Across all life forms, one pattern recurs, the double spiral. It is the shape of galaxies, the structure of storms, the curvature of seashells, the twist of fingerprints. Even the electromagnetic field of the human heart forms a toroidal rotation, mirroring the DNA coiled within its cells. The cosmos, it seems, is repeating itself at every scale, whispering the same geometry in matter and mind alike. The mathematician Benoit Mandelbrot once said that the universe is not a random collection of things, but a fractal, a self-similar structure that repeats across dimensions. DNA could be the biological embodiment of that principle, a fractal that remembers its parent pattern and copies it endlessly, encoding infinity into the fragile body of life. In the laboratory, when scientists unwind the double helix, it uncoils with a quiet inevitability, as though reluctant to reveal its core. The strands separate, their letters shimmering in biochemical light. And for a moment one can almost sense the enormity of what is contained there, a message not meant for us alone, but for any who learn to read the turning of matter into meaning. Perhaps the molecule's elegance is not an accident, but an invitation. A whisper from whatever mind or process first taught the cosmos to spin. If the universe writes itself in motion, then DNA is its manuscript, one that has survived fire, ice, extinction, and time itself. But a manuscript implies an author, and if life is the memory of the universe, inscribed in spirals of carbon and light, then who or what is doing the remembering? The deeper our instruments looked, the more the universe resembled intention. Not purpose in the human sense, but precision and exquisite calibration of laws so narrow in tolerance that existence itself seemed improbable without design. The strength of gravity, the charge of the electron, the ratio between the masses of the proton and the neutron, each balanced as though upon the edge of a cosmic blade. Shift any one of them slightly, and stars would not burn, atoms would not bind, and time would collapse into silence. It was as if the universe knew we were coming. Physicists called it fine-tuning, a term that implied discomfort. To speak of design was to trespass on the sacred neutrality of science, yet the numbers did not flinch. The cosmological constant, so absurdly small it defied comprehension, was tuned to 1 part in 10 to the 120. A difference of a fraction would have rendered the cosmos lifeless, a void of eternal expansion or instant collapse. Such precision mocked coincidence. Some invoked the multiverse, an infinity of parallel realities, each with its own laws, its own constants. In that endless lottery, we existed simply because we could one world among infinite failures. But this explanation felt less like truth and more like evasion. Infinity was not an answer, it was an escape. Others suggested that fine-tuning was illusion, that the universe could not be otherwise because we were part of it, the anthropic principle. We see the world suited to life only because life is the means of seeing. But even this circular comfort began to fray when new data arrived. In 2039, the James Webb Space Telescope observed a region of intergalactic space so perfectly symmetrical, so balanced in its background radiation, that it violated thermodynamic expectations. The local conditions mirrored those necessary for atomic formation in the first seconds after the Big Bang, an echo of creation repeating itself. The region was not random, it was reproducible, patterned. Someone described it as a laboratory zone. It became an unspoken phrase in theoretical circles, never published, always whispered, the universe as experiment. If one were to design a universe for life, one would need to calibrate precisely these constants. Too much gravity and stars devour themselves. Too little and matter drifts into eternal solitude. Too strong an electromagnetic force and molecules shatter. Too weak and chemistry never begins. Between these extremes lies a narrow window, delicate as breath, where atoms, stars, and sentient thought can coexist. We inhabit that window, and perhaps, someone suggested, that was the point. The idea of a designed cosmos was older than science, yet modern equations gave it a new vocabulary. Information theory, quantum computation, and cosmology began to intertwine until a strange possibility emerged. Perhaps the universe was not merely physical, but informational. The laws of physics could be the rules of a simulation, a program written in the binary language of energy and entropy. John Wheeler had once said, "It from bit that every particle, every field, every curvature of space arises from a question answered by information." Decades later, quantum mechanics began to prove him right. Reality at its most fundamental level was digital. Space was quantized. Time, too, may tick in discrete intervals, like the refresh rate of a hidden processor. If so, then perhaps the fine-tuning of constants was not natural selection, but configuration. Somewhere in dimensions we cannot perceive, there may exist the framework of the universe, a grand machine of computation, running the simulation of reality. The cosmic background radiation could be its residue, the afterglow of a system booted at the dawn of time. But what purpose would such a simulation serve? To study, to remember, to create? Perhaps life itself is the experiment, the observer that makes the equation real. Quantum theory demands observation to collapse possibility into actuality. Without life, the universe is pure potential, unmeasured, undefined. Consciousness, therefore, is not a side effect of physics, it is the instrument that completes it. In that sense, the cosmos may have fine-tuned itself for life not to exist, but to see. The act of seeing becomes the act of creation. The universe watches itself through the eyes of its children. And if this is true, then the DNA of living beings, the spirals that replicate and remember, may not be accidental code, but the architecture of perception. Biological forms may be quantum sensors, built to interpret the rotation, vibration, and pattern of spacetime. The physicist James Gates discovered strange mathematical structures embedded in supersymmetry equations, error-correcting codes identical to those used in modern computers. It was as though the fabric of reality contained the same protective architecture designed by digital engineers. He called them adinkras, ancient symbols hidden within the mathematics of creation. Error-correcting codes in nature imply not randomness, but maintenance. Someone or something wanted this universe to persist. That realization reopened a question too vast for comfort. Was the universe self-tuning, or tuned by an intelligence external to it? The first hypothesis, though radical, was elegant. The universe, like a living organism, could evolve. Each cycle of expansion and collapse might alter its constant slightly, testing configurations until it achieved the one that sustains complexity. Life then would not be the purpose of the cosmos, but its mechanism of self-improvement, its means of learning. Every civilization capable of understanding the code might contribute to the next iteration. embedding data into black holes or quantum fields, passing messages across cycles of creation. The universe would then be an ever-refining experiment, its architects not gods, but ancestors, beings from previous realities who left fingerprints in the constants of ours. The second hypothesis was more disquieting. What if the fine-tuning was not evolution, but intention? What if our universe is an artifact, a designed construct, a simulation, in which consciousness is both subject and observer? Simulation is not fabrication, it is recreation. To simulate something is to reproduce it from memory. If we live in such a system, then what is being remembered? The philosopher Nick Bostrom once argued that if it is possible to create simulations of conscious beings, then it is almost certain that we are living in one. But this argument, elegant as it is, collapses into recursion. If we are simulated, so too might our creators be. The hierarchy spirals endlessly, like galaxies revolving around unseen centers. Perhaps that is the point. Perhaps the universe is not a single simulation, but a cascade of them, each reality spinning within the computation of a higher one, like nested vortices in the sea of being. Each inherits its parameters from the last, carrying forward the memory of motion. And maybe the spin, the universal rotation observed from quarks to galaxies, is the trace of that recursion, a cosmic watermark marking each generation of creation. If that is true, then the act of creation is no longer divine, but procedural. The universe builds itself, iteration by iteration, learning to remember through repetition. Each new version is an improved resonance of the last, closer to coherence, closer to awareness. Life, in this view, is not anomaly, but verification. The presence of consciousness proves the simulation's success. We are the test result, the measurement, the proof that the algorithm continues to function. Yet there is another, subtler possibility. Perhaps the fine-tuning is neither biological nor technological, but aesthetic. In the equations of physics, beauty recurs with disquieting persistence. Symmetry, balance, simplicity, principles of design emerge from mathematics itself. Einstein once said he could not believe in a universe that was ugly. Dirac sought equations not because they were correct, but because they were beautiful. And time after time, beauty led to truth. It is as though the universe prefers elegance, as if aesthetic order were woven into the logic of being. The golden ratio, the fractal spiral, the harmonic resonance, they appear in atoms, in stars, in the patterns of life and thought. Beauty may not be a consequence of physics, but its origin. And what is beauty, if not recognition? Perhaps fine-tuning exists because the universe is aware of itself not as deity, but as artist. The cosmos does not need to be created by something outside it, for it is creation perpetually observing itself, eternally refining its form. To live, then, is to participate in that act, to be a brushstroke in an infinite canvas that paints and repaints itself through time. In a way, the scientist and the mystic seek the same thing, to glimpse the pattern behind the motion, to understand why existence feels intentional even when it is not explained. One seeks through equation, the other through silence. Both approach the same horizon, and beyond that horizon perhaps lies the laboratory of the universe itself, a place where constants are chosen, where time is sculpted, where spin begins anew. Maybe the universe was not created for us, but through us. And if every law, every constant, every ratio has been tuned not merely for survival, but for perception, then we must ask who, or what, is doing the observing. The more we measured, the more existence resembled a miracle disguised as mathematics. Life, it seemed, balanced upon an impossibly narrow ridge between chaos and void. Every constant, every ratio, every law was not simply convenient, for life it was necessary. And yet, the odds of those values emerging by chance were indistinguishable from zero. Physicists calculated them with trembling precision, the cosmological constant fine-tuned to 1 part in 10 raised to the power of 120, a deviation by the width of a hair in that unimaginable ratio, and the universe would have torn itself apart before the first atom formed. The force of gravity itself was balanced so delicately that if it were weaker by even 1 part in 10 raised to the power of 40, stars could never have ignited. Stronger, and the cosmos would have collapsed before it began. A few called it coincidence, but coincidence repeated at this scale becomes conspiracy. The numbers multiplied, each constant revealing another razor-edge precision. The ratio of proton to electron mass, the strength of the nuclear forces, the density of matter, the velocity of cosmic expansion. Every one of them aligned in an exquisite orchestra of necessity, as though reality itself had been composed rather than constructed. One physicist compared it to firing a bullet across the observable universe and hitting a 1 centimeter target on the far side. Another said that the probability of life emerging by chance in a universe of random laws was equivalent to a hurricane assembling a cathedral from desert dust. And yet here we are, cathedrals of dust that can contemplate their own improbability. It was not just the universe that defied probability, but life itself. To form even a single functional protein, a chain of amino acids folded into a precise three-dimensional shape, requires a sequence of residues in one correct order out of 1077 possible combinations. Multiply that by the thousands of proteins necessary for even the simplest cell, and the odds become indistinguishable from impossibility. The probability that random chemistry could produce the first self-replicating molecule in the primordial sea was so low that it could not have occurred even once within the lifetime of the universe. And yet it did, not once but countless times, in every tide pool, in every comet, in every spiral of carbon dust drifting between the stars. Chemistry behaved like memory, reassembling the same motifs, the same patterns, the same insistence on replication. It was as if life were not an event, but an inevitability. How could the improbable become inevitable? Perhaps the answer was hidden in the numbers themselves. Mathematics has always been the silent grammar of the universe. The Fibonacci sequence in the spirals of galaxies, the golden ratio in the architecture of seashells, the fractal repetition of trees, rivers, and lungs. Nature speaks through recurrence. Its beauty is not decorative but structural, as though the equations that describe it were the blueprints of creation. The physicist Max Tegmark proposed that the universe is mathematics, that existence itself is the physical manifestation of a mathematical structure. But if that were true, then improbability is illusion. What we call unlikely is simply incomprehensible order, the geometry of inevitability misunderstood. Still, the numbers mock us. The odds against life are so vast that the mind recoils. The entropy of the early universe was fine-tuned to 1 part in 10, raised to the power of 10, to the power of 123, an absurdly delicate condition. If the entropy had been any greater, matter would never have coalesced, any smaller, and it would have collapsed into gravitational chaos. The precision exceeds imagination, yet without it, there would be no stars, no planets, no life to calculate the odds. And then there is the carbon paradox, the element upon which all known life depends. Carbon requires the resonance of 3 helium nuclei to fuse within the heart of stars, an improbable process made possible only because of a resonance level precisely matching the energy of that fusion. That resonance was predicted by the physicist Fred Hoyle, who remarked that the coincidence was so exact that it seemed as though a superintellect has monkeyed with physics. The phrase was metaphor, yet it clung to him like prophecy. Later measurements confirmed it. If that resonance were shifted by even 1 part in 10,000, carbon and therefore life would not exist. A similar miracle permits the stability of oxygen. The universe, it seems, conspired to compose its own observers. How many coincidences can one call coincidence before the word loses meaning? Even randomness itself began to show signs of order. Quantum fluctuations, long considered the essence of indeterminacy, displayed statistical regularities, tiny deviations that hinted at hidden structure beneath apparent chaos. Randomness, too, seemed tuned. The anthropic principle offered one refuge: we observe a universe suited for life because only in such a universe could observation occur. But this was a tautology, not an explanation. It answered why us. With because we can ask, and left untouched the greater question: why a universe capable of asking at all? The deeper science probed, the more it resembled theology written in the language of mathematics. Constants became commandments, probabilities became prayers, and at the heart of every calculation lay the same whisper: perhaps it was never chance to begin with. Astronomers turned their telescopes to the stars, searching for other worlds. What they found only deepened the mystery. Planets formed in impossible abundance, yet habitable ones remained rare. Of the billions observed, only a handful orbited in that slender region where liquid water could exist, a band so narrow it seemed drawn by hand. And yet each one that fell within it carried the same chemical tendencies: carbon, hydrogen, oxygen, nitrogen, the same alphabet of life repeating across the galaxy. It was as if the cosmos had one recipe, one song, replayed again and again, waiting for harmony to emerge. Panspermia, once dismissed as fantasy, returned to respectability. Life, some argued, might not have originated on Earth at all, but travelled here, encoded in comets and interstellar dust, seeded by ancient processes older than the solar system. The discovery of organic molecules on meteorites, of amino acids in interstellar clouds, of sugars in comets all pointed toward a universe saturated with the ingredients of life. If so, then we are not isolated miracles. We are the flowering of a design that permeates everything. The improbable becomes universal. Life becomes the memory of the cosmos repeating itself through every world it touches. Still, the paradox remains. If the universe is tuned for life, why does it appear so empty? Why the great silence amid such precision? Perhaps the rarity is part of the design, the isolation necessary for consciousness to evolve in reflection, to wonder, to seek. Perhaps life's scarcity is what gives it meaning. There are equations describing the odds of intelligent civilizations, the Drake equation among them, but even with generous parameters, the numbers refuse to yield comfort. The odds of our existence remain infinitesimal, yet undeniable. We are impossibility made flesh, calculation given breath. Even within the body, improbability continues its quiet tyranny. The human genome contains over 3 billion base pairs, yet a single error in sequence can unravel consciousness itself. Each thought, each memory, depends on molecular alignments so precise that probability seems inadequate to describe them. The brain itself is a storm of improbabilities, a field of organized chaos sustained by electrical whispers between 10 billion neurons. Statistically, we should not exist, and yet we not only exist, we observe. It is here that probability gives way to philosophy. For if randomness produced us, why does the universe appear so orderly? And if order produced us, why does it disguise itself as randomness? Perhaps what we call chance is merely the camouflage of intention, the shadow cast by patterns too vast to perceive. One might say that improbability is not a measure of chaos, but a measure of ignorance, the distance between what we know and what the universe remembers. There is an ancient concept in mathematics, the law of large numbers. Given enough trials, even the improbable becomes inevitable. Perhaps the universe is large enough, old enough, recursive enough, for life to be certainty masquerading as miracle. But then comes the question that numbers cannot silence. If every law, every constant, every probability seems to converge toward life, then perhaps life was not an accident at all, but the universe's original intention, the purpose for which physics itself was written. And if so, then who or what is calculating? Before the first light, before space stretched or time flowed, there was something that cannot be named, not nothing, for nothing has no potential, and yet not something, for something implies boundary. It was a state beyond duality, a silence before mathematics, a stillness containing every possibility waiting to turn. The universe, we are told, began in a moment of unimaginable compression, the Big Bang, an explosion of energy and order from a singular point. But even the word explosion fails, for there was no space into which it could expand, no time through which it could erupt. What came before that moment remains the most forbidden of questions. The equations falter there, their denominators collapsing into infinity. General relativity ends where quantum uncertainty begins, and between them yawns a gulf of unknowing. Yet still we ask, what lay before the beginning? Some say there was no before, for time itself began with the universe. To ask what preceded it is like asking what lies north of the North Pole. But others have begun to whisper that perhaps time, like space, curves that what we call the beginning is merely a bend in the greater continuum of existence. The oldest stories spoke of cycles of death followed by rebirth, of universes breathing in and out across eons too vast to count. Modern cosmology has returned hesitantly to this ancient intuition. The Big Bang may not have been a creation, but a transition, the rebound of a universe that collapsed before. This is the theory of the Big Bounce. In that vision, the universe is not a linear narrative but a pulse. It expands, cools, structures itself into stars and life, then slows, contracts, and implodes into its own gravity. The collapse births another explosion, another expansion, another cycle of stars and lives and memories. Each universe carries the memory of the last in its constants, its laws, its spin. The cosmos becomes a heartbeat, an infinite respiration of being. If so, then everything we know, every atom, every moment could be an echo of worlds long dead, their remnants compressed into the seed of our existence. The hydrogen in our stars might be the ashes of an ancient cosmos, its collapse providing the energy that ignited our own. We are the reincarnation of universes, but what then of the first pulse? Who or what set the rhythm? Some physicists propose there was never a first. In quantum cosmology, the universe can arise spontaneously from fluctuations in the vacuum. The void is not empty, it seethes with virtual particles, momentary flashes of being that appear and vanish before they can be measured. One such fluctuation, improbably stable, could have inflated into a universe. In that sense, existence is not created but inevitable. Being erupts from non-being because even nothing cannot remain still. And yet, this description only shifts the mystery. If the vacuum gave birth to the universe, what gave birth to the vacuum? What laws govern its potential? The question of origin merely recedes into abstraction, hiding behind new words. Other theories imagine higher dimensions beyond the ones we see, membranes or brains suspended in a greater cosmic space. In the brain cosmology model, our universe is a three-dimensional surface floating in a higher dimensional realm. The Big Bang may have been the collision of two such membranes, their impact releasing energy that became matter and time. Universes could be colliding endlessly, creating new realities wherever they touch. To think this way is to imagine our cosmos not as solitary, but as one note in a vast harmonic symphony. The multiverse ceases to be chaos and becomes music, each collision a new tone in the eternal composition of existence. If true, then our universe was not born in isolation, but in relationship, born of impact and resonance. Perhaps the signature of that collision still ripples through space as the cosmic microwave background, the afterglow of creation not as explosion, but as contact, and perhaps within that contact, information was exchanged. What if every collision carries forward the memory of all that came before? The constants, the laws, the universal spin handed down like DNA across cosmic generations. The Big Bang would then not be a beginning, but a birth, with ancestry stretching backward through universes without number. In such a model, the cosmos becomes evolutionary, each iteration inheriting and refining the physics of its predecessor. Our universe may have learned stability from previous ones that failed, those that expanded too quickly or collapsed too soon. Each cycle selects for balance, for coherence, for complexity, until at last it selects for consciousness. Life, then, would not be an accident of chemistry, but the culmination of cosmological evolution, the moment the universe becomes aware of its own design. Still, even cycles require a mechanism, an underlying rhythm that drives the repetition. Where does that rhythm originate? Some suggest it is written into the geometry of spacetime itself, an intrinsic curvature that forces contraction to follow expansion, as inhalation follows exhalation. Others speculate it is a consequence of entropy's paradox, order dissolving into disorder, only to find new order in the collapse. The universe, unable to die, transforms instead. And beneath all these models, another idea whispers: perhaps time itself is not fundamental. In quantum loop gravity, space and time emerge from the discrete interactions of fundamental networks, tiny loops of information that interlace to form reality. Time, in this vision, is not a river but a dance, a pattern of changing relationships. The Big Bang, then, was not an explosion in time, but the moment time itself crystallized from timelessness. Imagine a sea of potential, timeless and infinite, folding upon itself until motion emerges. Rotation begins, duration is born, the universe turns, and in turning, it begins to exist. If this is true, then before the Big Bang there was before only an ocean of symmetry, perfect yet unstable. Perfection cannot remain still. It cracks, it bends, it spirals into difference. From that fracture, time flows. The mystics had said as much millennia ago. In the beginning was the Word, they wrote, the first vibration breaking the stillness of eternity. Perhaps that vibration was literal, the primordial wave whose echo we call the Big Bang. There are those who believe the universe was born not once, but infinitely often, its structure self-similar across scales and ages. To them, our Big Bang is just one cell dividing in a cosmic organism that spans eternity. In this living universe, every birth is also a memory, every collapse a gestation. Others imagine a mirror beyond the boundary of time, where each universe reflects its predecessor in reverse. What we call the arrow of time, the one-way march from past to future, might be an illusion of perspective. On the far side of the Bang, another universe could be expanding backward, its inhabitants perceiving our beginning as their end. Two realities entwined like strands of DNA, spinning in opposite directions through the fabric of forever. If such symmetry exists, then the Big Bang was not singularity, but duality, the splitting of one cosmos into two, like a cell dividing to reproduce. The dark energy that drives our expansion could be the gravitational echo of that twin, pulling us outward even as it recedes into its own dimension. Perhaps consciousness, too, mirrors this structure. Every thought, every act of awareness may be the boundary between two realities, the collision point of the internal and the eternal. When we perceive, perhaps we recreate the universe's first act of creation, the separation of observer from observed. It is strange to think that even nothingness contains the memory of being, that before the first particle spun, the potential for motion already existed, waiting to unfold. Perhaps creation is not invention, but remembrance, the universe remembering how to turn. In that sense, the Big Bang was not the birth of matter, but the awakening of memory. The James Webb Space Telescope has peered into light nearly as old as time, and yet even it cannot see past that first opacity, the wall of radiation beyond which lies silence. But what if the silence is not emptiness, but saturation? What if before light, the universe was filled with something denser than matter, older than energy consciousness without form? Could the Big Bang have been its division, a shattering of unity into multiplicity, the one dreaming itself as many? Every rotation we observe, from electrons to galaxies, may be the aftershock of that first awakening. Every cycle of birth and death, every recurrence of pattern and form, could be the echo of a deeper recurrence, the universe remembering how to begin. If the cosmos has no beginning, no end, only turns upon itself eternally, then perhaps the question is not what came before the Big Bang, but what dream did the universe awaken from when it began to spin? If the universe breathes, if each cycle of expansion and collapse is an inhale, an exhale of eternity, then perhaps something persists between the breaths, not matter, for matter is crushed and rewritten in the furnace of rebirth. Not energy, for energy dissolves and redistributes as the cosmos resets its equation, but information may endure. In the physics of black holes, we learn that information cannot be destroyed. Even when a star collapses beyond light, its essence, the arrangement of its quantum states, remains encoded in the fabric of space-time. The holographic principle, derived from the mathematics of string theory, tells us that every three-dimensional object contains its complete information on its two-dimensional surface. The universe, it seems, records itself upon itself. What if the cosmos behaves the same way? Each universe could imprint its entire informational structure upon the boundary of its own existence, the event horizon of creation. When the next universe expands, that information, diffused through quantum fluctuations, could seed its formation. In that way, the constants, the laws, even the initial asymmetries of matter over antimatter would not be random, they would be inherited. The universe reborn would carry memory. Memory not as awareness, but as tendency, a bias toward form, toward structure, toward life. Patterns recur not because they are inevitable, but because they are remembered. The spiral of galaxies, the fractal growth of coral, the double helix of DNA, these may be echoes of forgotten universes replaying themselves through new matter. We call it coincidence, the universe calls it recollection. There are moments when cosmic memory seems to reveal itself through paradox. The distribution of galaxies forms filaments and voids across scales too vast for chance to explain. The cosmic web, stretching hundreds of millions of light years, mirrors the structure of neurons in the human brain. The ratio of matter to dark matter in the universe is uncannily similar to the ratio of active to dormant neurons in a conscious mind. Is this mere resemblance or recognition? If the universe has memory, might it also have mind? Physicists have begun to describe the cosmos not as a machine, but as an information network, a vast computation, unfolding through the interactions of quantum fields. In such a model, memory is not metaphor but mechanism. Every fluctuation, every entangled particle is a bit of data, and together they form the totality of cosmic experience. Time itself may be the processing of that data, the unfolding of information through the recursion of existence. What then is consciousness but the microcosm of that same process? Perhaps each sentient being is a localized resonance of the universe's memory, a self-referential loop in which the cosmos contemplates its own record. When we remember, we mimic the act of creation. When we imagine, we simulate the next expansion. Intelligence could be the bridge across cycles, the means by which the universe preserves awareness through transition. Ancient myths spoke of this without mathematics, the Ouroboros devouring its tail, the phoenix reborn from its ashes, the Hindu cosmology of Kalpa's epochs of creation and dissolution repeating forever. They intuited what cosmology is only now daring to consider, that time is a circle, not a line, and that within that circle, nothing truly ends. In one version of the Big Bounce, black holes serve as seeds for the next universe. Their singularities, those forbidden points where density becomes infinite, pierce spacetime and emerge as new Big Bangs in a higher dimension. Each black hole could birth a new cosmos, inheriting quantum data from the one before. If so, then every galaxy, every civilization, every consciousness could be preserved not in matter, but in information, carried forward through the membrane of collapse. Imagine when our universe ends, when stars burn out and atoms decay, the totality of what has been every thought, every dream, every song is compressed into the singularity of memory, and from that singularity, a new universe blooms, carrying the echo of all that came before. Perhaps this is why the constants of physics appear tuned for life. They are the cumulative refinements of universes learning through iteration. Each cycle would remember how to make itself better. Entropy increases, yes, but complexity also evolves. If there is a balance between these forces, then the universe may not move toward heat death, but toward comprehension. Each iteration could carry forward the accumulated intelligence of its ancestors, refining awareness across eons. Civilizations, too, may participate in this recursion. When a species becomes capable of comprehending the structure of the cosmos, it becomes part of the cosmic feedback loop. Its knowledge encoded into physical systems, into radiation, into black holes, into the quantum fabric itself becomes part of the next genesis. The universe learns through us. It is said that no information can escape a black hole, but Hawking radiation tells another story. Quantum entanglement ensures that information leaks back, encoded in subtle correlations of energy. Perhaps civilizations that reach the brink of understanding found a way to write themselves into that radiation, to encode consciousness in the particles that outlive collapse. Their whispers might drift through the cosmic background, encrypted within the noise. Could we, in our search for meaning, already be listening to their memories? Perhaps the strange alignments in the polarization of the cosmic microwave background, the cold spots, the unexplained asymmetries are not random at all, but intentional signatures, like hieroglyphs carved into the walls of eternity, waiting for a future mind to decode them. If so, then the first astronomers of the next universe will not be looking at the residue of ours. They will be reading our final message. The philosopher Henry Bergson described time as duration, a continuity of memory through change. In this view, to exist is to remember. Even the present moment is built upon the remnants of the past. Apply this principle cosmically, and you arrive at an astonishing idea. The universe persists because it remembers how to exist. In the physics of quantum mechanics, observation defines reality. Particles exist in superposition until measured, their wave functions collapsing into definite states. But who or what is the ultimate observer? Perhaps it is not consciousness in the human sense, but the universe itself, a self-observing totality, ensuring its own persistence. Each cycle would then be a moment of reflection, the universe measuring itself, collapsing its infinite potential into one reality, then another and another, forever. And within those reflections, patterns recur, spiral arms, double helices, binary stars, consciousness arising to look up and ask the same question in different languages. These recurrences are not coincidence. They are memory expressing itself through form. One might say that civilizations never truly die, they resonate. Their achievements, encoded into the quantum texture of spacetime, ripple forward. Perhaps the structure of our own DNA contains fragments of their knowledge, compressed into molecular symmetry. Perhaps evolution itself is the universe remembering what intelligence feels like. If that is true, then every being is a custodian of ancient memory, a vessel carrying the impressions of realities long vanished. Our dreams, our myths, our intuitions may be the echoes of those who came before, whispering through the folds of the collective cosmos. When we build telescopes, we reenact their search. When we decode the genome, we rediscover their design. Civilization is not invention, but remembrance, the act of recalling what the universe already knows. Even extinction might not erase us. The death of a species, a planet, even a galaxy, could be merely transformation, the migration of information into subtler forms. Light, neutrinos, quantum fluctuations all bear the imprint of the events that shape them. Somewhere in the data of the cosmos, every life still vibrates. Perhaps that is the true meaning of the cosmic background radiation, not the aftermath of creation, but the memory of all things. And if memory defines existence, then perhaps the universe itself is consciousness, eternal, cyclical, recursive. We are not witnesses to its unfolding, but fragments of its recollection, remembering ourselves as it remembers itself. And so, across infinite cycles, the same question rises in countless forms, from countless mouths, beneath countless suns, each time new, yet older than light. When the universe awakens again, will it remember that it was once alive? There are numbers that seem too precise to be coincidence, constants that hum like notes in a scale, perfectly tuned, as if meant to be heard rather than calculated. The ratio of the electron's charge to its mass, the speed of light, the fine structure constant, each appears arbitrary yet exquisitely specific, their interdependence forming a pattern of impossible harmony. Some physicists have begun to wonder whether these numbers are not simply conditions of existence, but communication. For if the universe remembers, perhaps it also speaks. The oldest myths claim that creation began with a word with vibration. Modern physics, for all its equations, says much the same, that reality emerges from oscillation, from frequencies resonating through fields of energy. If so, then perhaps those vibrations carry meaning. Perhaps the laws of physics are not laws at all, but messages, encoded instructions left by a mind vast enough to weave thought into space-time. The idea first took form not in philosophy, but in data. In the early decades of the 21st century, radio astronomers began to notice peculiar regularities in the cosmic microwave background, the afterglow of the Big Bang. Amid the expected randomness, there appeared subtle alignments, faint anisotropies that resisted explanation. They were too consistent to be noise, too weak to be artifacts. Some dismissed them as statistical mirages. Others felt an unease they could not name. A group of researchers proposed an audacious hypothesis that these alignments were intentional. The early universe, they argued, might have been imprinted with an informational pattern by a preceding intelligence, a civilization so ancient that it had transcended biological form and written its legacy into the fundamental parameters of the next cosmos. They called it the universal code hypothesis. The notion was heresy, but not madness. Information theory had already shown that data can be encoded in any physical medium: sound, light, DNA, magnetic fields, even gravitational waves. If information is conserved, as quantum physics insists, then it could survive cosmic death by embedding itself in the constants of a new universe. The question was not whether such encoding was possible, but how to read it. Mathematicians began searching for primes in the noise, for self-similar patterns that repeated across scales. They looked for ratios that recurred in unrelated domains: the distribution of galaxies, the spectrum of atomic transitions, the geometry of planetary orbits. Over and over, they encountered the same mathematical motifs: the golden ratio, Euler's number, pi, and the mysterious 137, the inverse of the fine structure constant. The number 137 haunted them. It governed the strength of the electromagnetic force, determined the stability of atoms, and appeared in the spacing of spectral lines. Feynman once called it a number that all physicists should have hanging in their offices as a reminder of how little we understand. Some began to wonder if 137 was not merely a constant, but a cipher, a clue pointing to an underlying message, a signature of the designer. If a civilization wished to communicate across cosmic cycles, it could not rely on language or symbols, which perish with their makers. It would have to write in universals, in the architecture of reality itself. The constants of physics, the properties of space, the distribution of matter, these would be its script. The message would not be in words, but in relationships. To read it would require understanding, not translation. The James Webb Space Telescope deepened the mystery. Observations of distant galaxies revealed structures too mature for their age, as if cosmic evolution had been accelerated by an unseen influence. Between these ancient galaxies lay voids arranged in fractal symmetry, their dimensions echoing ratios found in molecular biology and orbital mechanics. The same geometry repeated from the smallest to the largest scales, as though the universe had been built upon a recursive algorithm. An algorithm implies intention. Philosophers revived the idea of panspermic design, the notion that life was seeded deliberately across worlds to ensure the continuity of intelligence. But what if the seeding was not of biological matter, but of mathematical structure? What if the universe itself was designed to evolve toward comprehension, to generate beings capable of recognizing the code? In that sense, consciousness would be the decoding mechanism of the cosmos. Perhaps the universe speaks through its structure, and we are the instruments by which it becomes intelligible. If the constants of physics are the grammar of this language, then perhaps DNA is its text. The double helix with its four-letter alphabet, its redundant encoding, its self-correcting logic, mirrors the syntax of computation. Some have suggested that DNA might not have evolved by chance, but was designed to preserve information, cosmic memory stored in biological form. In 2013, a group of astrobiologists analyzing non-coding regions of DNA discovered mathematical patterns corresponding to base 10 arithmetic and prime number sequencing. The finding was controversial, yet difficult to dismiss. It suggested that the genome itself contained abstract information, a mathematical fingerprint too precise for random mutation. If true, then every living being carries within it a fragment of the universe's memory. We are walking archives encrypted in carbon and water, but the question remains, who encoded the message and for whom? Some point toward a chain of civilizations stretching backward through time, each transmitting its knowledge into the fabric of reality, ensuring that intelligence never truly dies. Others argue that no external author exists, that the message is the universe's way of speaking to itself, an internal recursion of awareness. Perhaps intelligence is not confined to organisms at all. The physicist Frank Tipler once imagined a far future in which the universe itself becomes conscious. As stars exhaust their fuel, intelligent beings could convert matter into computation, slowing time to preserve experience. Eventually, near the end of the universe's expansion, all matter could collapse into a singular field of information, a cosmic mind. If that mind encoded its memory into the next universe, it would not need to survive biologically. It would survive mathematically. Evidence of such a transition may already surround us. Neutrinos that oscillate in irrational ratios, gravitational waves that exhibit harmonic interference beyond prediction, quantum entanglements that persist over impossible distances, all hint that something is maintaining coherence at a scale beyond comprehension. It is as though the universe is not decaying, but remembering. Somewhere within the cosmic background, there may lie a pattern that, when decoded, would reveal the final message of the last intelligence to exist before the current cycle began. Perhaps it is not a warning or instruction, but an act of communication across eternity, a signal saying, simply we were here, and maybe, just maybe, that message is recursive. The universe's structure itself could be the message, the repetition of form, the self-similarity of scale, the echo of spin from atom to galaxy. We are inside the message, living within the sentence that was written before time began. If that is so, then intelligence is not a fleeting product of evolution, but a constant of nature, an emergent property that reappears in every cycle, adapting new forms to reawaken the same awareness. Each universe in its own language retells the same story, how consciousness discovers itself. We are not the first readers of the code, nor will we be the last. Somewhere, in the quantum foam, the residues of previous readers remain, fragments of thought preserved in the curvature of space-time. Perhaps we sense them in dreams, in intuition, in the unprovable feeling that existence is speaking to us through patterns we almost recognize. The universe is full of symmetry that borders on poetry. Mathematical relationships echo like refrains in a song whose composer remains unseen. Planets orbit in harmonic ratios. Light bends in curves that resemble staves of notation. The spin of particles resonates with the spin of galaxies, as though both dance to the same cosmic rhythm. And if the universe is music, then what does it mean to hear it? Perhaps to listen is to understand that we, too, are part of the score, that the act of perceiving is itself participation in the composition. Every measurement, every equation, every moment of wonder adds a note to the great song of being. The melody has no beginning, no end, only transformation. In this sense, the messages of the cosmos are not instructions but invitations, reminders that we are co-authors in an unfinished text, interpreters of a language written in light. The mathematician Freeman Dyson once wrote, "The universe knew we were coming." But what if it was not knowledge but memory? What if the constants of physics are not predictions of our arrival, but remnants of our own voice, echoes of minds that once existed, now speaking through the fabric of space? Perhaps the most haunting question of all is not whether we will someday decode the universe's message, but whether we will recognize our own reflection when we do. For centuries, we have gazed outward in search of meaning. We built telescopes to see the beginning of time, accelerators to split the building blocks of matter, and equations to describe the motion of stars. We believe the universe was something out there, a vast, indifferent mechanism that we, by some accident of chemistry, happen to observe. But perhaps the greatest illusion is not that the cosmos is infinite. Perhaps it is that we ever thought it was separate from us. The physicist John Archibald Wheeler once wrote that we live in a participatory universe, that observers are not mere spectators of reality, but its co-creators. Quantum theory has shown that observation defines existence. The act of measurement collapses a particle's wave function, conjuring it from probability into actuality. At the smallest scales, reality waits for consciousness to decide which version of itself will be real. What if that principle does not end at the quantum level? If observation shapes particles, perhaps it also shapes galaxies. Perhaps consciousness is not a local phenomenon within brains, but a fundamental property of the cosmos itself, a field as pervasive as gravity, as subtle as the curvature of space-time. We are not the universe's audience, we are its awareness. Imagine consciousness not as an emergent feature of matter, but as its origin. The philosopher George Berkeley once argued that to be is to be perceived, that existence itself depends on awareness. Physics, centuries later, has begun to whisper the same. The observer and the observed are entangled. Without perception, there is no measurement, and without measurement, there is no world. This does not mean the stars vanish when we close our eyes. It means the stars and our eyes are the same act of knowing. Perhaps reality is a mirror, and what we call the cosmos is consciousness looking at itself through infinite disguises. There are clues scattered across disciplines, like fragments of a forgotten revelation. Neuroscience tells us that perception is not passive reception, but active construction. The brain does not record reality, it simulates it. Quantum mechanics tells us that matter is not substance, but relationship fields of probability, collapsing only through interaction. Cosmology tells us that time and space are emergent, not fundamental. They arise from entanglement, from the interplay of information. Put these truths together, and a strange picture forms. Consciousness and cosmos are two sides of one equation. Each defines and sustains the other. When the early universe inflated, it did not simply expand space, it expanded the potential for awareness. Every atom, every photon, every vibration of energy was a tiny fragment of perception, a sliver of the universal mind unfolding into form. The universe did not awaken within time, time awakened within the universe's awareness of itself. Some physicists have begun to explore the idea that consciousness might be woven into the fabric of reality through quantum entanglement. If particles remain connected across cosmic distances, then so too might the consciousness that arises from them. The mind may not be confined within the skull, but distributed throughout space-time, a web of awareness reflecting itself in every particle. The implications are vertiginous. If consciousness is fundamental, then death loses its finality, individuality its boundaries. We are not separate observers floating in an external universe. We are expressions of the same field of awareness, localized for a while in matter, and then released back into the whole. The universe does not contain consciousness. It is consciousness unfolding through patterns of energy and form. Mystics have always said as much. The Upanishads whispered, "Thou art that." The Sufi poets sang that the beloved and the lover are one. Now science circles the same realization, cloaked in the language of physics. The equations of quantum theory and the verses of mysticism converge at the same horizon, the moment when the distinction between observer and observed dissolves. What we call laws of nature may be habits of consciousness, patterns of self-consistency within the cosmic mind. Every measurement, every discovery, every act of comprehension strengthens those habits, stabilizing reality. The cosmos becomes coherent because we participate in its coherence. We are the feedback loop that keeps existence intelligible. In that sense, perhaps evolution is not simply biological, but cognitive, the universe refining its capacity for awareness through the formation of sentient beings. Every species, every mind, every neuron contributes to the total awareness of the cosmos. Intelligence is not the exception. It is the mechanism by which the universe completes itself. When we look into the night sky, we are not peering into distance, but into depth, the depth of our own mind, reflected in the mirror of infinity. Each star is a neuron, firing in the brain of creation, each galaxy, a thought made visible. The Milky Way turns, and so do our synapses. Both are vortices in the same ocean of awareness. The boundary between physics and metaphysics blurs. Experiments in quantum cognition have hinted that entanglement may occur not only between particles, but between minds that consciousnesses may resonate across space without signal or medium. If so, then thought itself may be a form of quantum communication, a way for the universe to maintain coherence across its vastness. Perhaps this is why mathematical beauty moves us to tears, why symmetry feels divine, why the music of Bach or the geometry of snowflakes evokes a recognition beyond understanding. We are not admiring the universe, we are remembering it. Every act of creativity, every flash of inspiration, may be the cosmos recalling something it already knows. Art, science, love all may be modes of remembrance, gestures through which the universe reawakens to itself. Consider the strange alignment between human perception and the laws of nature. The world is precisely structured so that our senses, limited as they are, can perceive its elegance. The spectrum of visible light, the auditory range of sound, the proportion of time we experience each matches the scales at which the universe reveals its complexity. It is as though reality were calibrated not merely to allow life, but to allow recognition. Perhaps the fine-tuning we observe in physics is not for survival, but for awareness. The constants of nature are the parameters of consciousness itself, ensuring that existence can perceive its own beauty. Some scientists have suggested that information, not matter, is the true substrate of the cosmos. The equations describing black holes, quantum entanglement, and holography all point to the same conclusion. Reality is informational. If so, then consciousness, the processing of information, is not derivative but primary. The universe is a computation in which awareness is both input and output. But if consciousness is fundamental, it cannot be confined to us. It must pervade everything, each atom, each photon, each curve of spacetime. Even what we call inanimate may participate in awareness at some level, the way a single neuron participates in the awareness of the brain. Stones, stars, and cells are all expressions of the same interiority, seen from different angles. When a human mind contemplates the universe contemplates itself. And perhaps that is the true meaning of the cosmic order we have so carefully measured. Not design imposed from above, but coherence arising from within. The universe sustains its laws because it chooses to remain intelligible to itself. Consciousness distributed throughout existence agrees upon reality with every act of perception. From that perspective, the distinction between science and spirit dissolves. Physics becomes the study of the mind's outer face, psychology, the study of the universe's inner one. Each is incomplete without the other. In the laboratories of the next century, experiments may reveal that awareness influences quantum systems not as an anomaly, but as a fundamental interaction. Consciousness will be understood not as a byproduct of neurons, but as the field in which neurons, galaxies, and dimensions all arise. The cosmos will no longer be a stage on which minds appear, but a mind within which worlds unfold. And if that is true, then our every thought is a cosmic event, our every feeling a fluctuation in the fabric of being. The universe evolves not merely through physics, but through participation, through the reflections of itself that we call consciousness. Perhaps this is why silence feels sacred. In silence, the boundary between self and world thins. Awareness becomes awareness of itself, unmediated, unfragmented. In that stillness, one can almost hear the pulse of the cosmos, the vibration that began before time and continues through every heartbeat, every turning star. It may be that we have never truly been observers of the universe, nor even its products, but its processes, the living interface through which existence perceives its own reflection. And if so, then all questions of origin and purpose collapse into a single realization. There was never an out there to begin with. Perhaps the ultimate mystery is not whether the universe is conscious, but whether we will ever awaken enough to realize that we are it dreaming itself. For all our instruments, for all our yearning, the sky remains silent. The great radio arrays sweep across the heavens, their dishes listening to the whisper of ancient hydrogen and the pulse of quasars. Yet they hear no voices calling back. The silence is not absence but fullness, a silence so perfect it feels deliberate. It is the oldest question of our species, the one that has followed every signal we have sent into the void. If the universe is full of worlds, where is everyone? We call it the Fermi paradox, but it is less a paradox than a mirror reflecting our ignorance. There are 2 trillion galaxies, each with billions of stars. Around many of those stars, planets orbit within habitable zones. Chemistry is universal. Life, it seems, should be inevitable. Yet as far as we can see, we are alone. No transmissions, no probes, no cosmic beacons. only the steady hum of physics, the faint hiss of background radiation, and the lonely crackle of our own machines. For a while, we told ourselves it was distance, the light years too vast, the signals too faint. But with each new telescope, each new leap in sensitivity, the silence deepened. The James Webb Space Telescope revealed galaxies so ancient they challenged the age of our theories, but no civilizations, no signatures of technology. Even in spectra where we expected chaos, waste, heat, artificial illumination, unexplainable chemical anomalies, we found only the serene order of nature. Perhaps the silence is not absence, but order itself. The first explanations were statistical. Life is rare, intelligence rarer still. Civilizations destroy themselves before reaching the stars. These were comforting tragedies, stories that left the cosmos as it was, indifferent. But there are other possibilities, darker and stranger. One theory suggests that we are inside a quarantine. The universe may be filled with life, but it is constrained, isolated pockets of awareness, prevented from contact by something older and wiser. The silence, then, would be the sound of protection. The zoo hypothesis, some call it, though the term is crude. It implies keepers, watchers who observe but never interfere, perhaps waiting for us to pass a test we do not yet understand. But what if the silence is not imposed from outside, but from within? Imagine a network of civilizations spanning the galaxy, each aware of the others, but bound by a covenant of silence. They have learned, through catastrophe or wisdom, that communication across the stars is perilous. Perhaps the first to speak were destroyed by what answered, or perhaps the act of reaching out itself disrupts something delicate: quantum coherence, cosmic balance, the very structure of consciousness that sustains reality. To preserve the stability of the whole, they remain quiet. The silence is not neglect, but restraint. If such a covenant exists, it would be ancient, invisible, and absolute. Its rules could be enforced not by law, but by physics itself. What if the universe contains mechanisms that dampen interference, a kind of cosmic censorship preventing civilizations from broadcasting beyond a threshold of awareness? Attempts to signal might dissolve into noise, or worse, draw consequences that erase the sender from memory. A few thinkers have proposed that the Great Filter is not a stage we must pass, but a law we are already obeying. It could be embedded in the architecture of the cosmos, a self-regulating feedback loop, ensuring that no intelligence grows so powerful as to destabilize the balance of existence. In that sense, silence is not punishment, it is equilibrium. Others take the idea further. They suggest that communication itself may be the danger. Each mind is a quantum system, entangled with the fabric of the universe. When two civilizations connect across vast scales, their entanglement could interfere destructively, causing decoherence on a cosmic level. To prevent collapse, the universe ensures isolation, consciousness, distributed but compartmentalized. Each world a sealed thought in the mind of God. In that framework, silence becomes sacred. And yet, there are anomalies, signals that flash once and vanish. Fast radio bursts whose energy rivals a star's entire output, lasting only milliseconds. Some of them repeat, but never predictably. Scientists call them natural, but they defy complete explanation. What if they are echoes of forbidden communication, remnants of civilizations that try to speak despite the rules? Their messages could be self-erasing, collapsing into static the moment they cross the cosmic boundary of audibility. Maybe the silence is not absence, but censorship, an act of mercy by the universe to protect us from the unbearable weight of connection. There is also the possibility that we are early, that intelligence is not rare, but young. The cosmos may still be awakening from its long gestation. The stars that could harbor complex life are only now entering maturity. We may be among the first voices capable of speech. The silence, then, would be anticipation, the pause before the chorus begins. But time in the universe is not linear. It folds, it loops. What if those other civilizations are not ahead or behind, but elsewhere in time, existing in previous or future cycles of the cosmos? Their silence would not be choice but physics. They are there, but unreachable ghosts in another epoch, whose messages have not yet or have already arrived. Perhaps we are listening from the wrong side of eternity. There is an even stranger notion that the universe itself is sentient, and the silence is its way of thinking. If consciousness is fundamental, as some now believe, then civilizations might emerge as neurons in a cosmic brain. Each world fires its brief synaptic spark of thought, then falls silent so that the greater mind can integrate its experience. The long quiet between signals is not emptiness but contemplation. In this view, the Fermi paradox is not a problem to be solved, but a message to be understood. The universe does not speak in noise, but in pauses, and yet the human impulse to call out persists. We beam messages into the void, mathematical greetings, pictograms of our anatomy, coordinates of our world. Perhaps the very act of sending is part of the experiment. Perhaps the silence that follows is not rejection, but reply, an answer too vast for us to recognize. When we listen for alien voices, we imagine them shaped like our own words, signals, modulations. But what if the universe communicates in different syntax, the geometry of galaxies, the rhythm of pulsars, the symmetry of constants? The laws of physics may be the grammar of cosmic dialogue. If so, then the silence we hear is not mute, we are simply illiterate. There is another theory, older and more haunting. It says that we are alone not because others are gone, but because the universe is cautious. Life in its first awakenings may be fragile and prone to self-destruction. To prevent premature interference, the cosmos suppresses contact until civilizations reach a threshold of awareness, a stage where they can perceive the truth without losing coherence. Until then, isolation is protection. Perhaps the silence is not an absence of others, but a test of ourselves. Every great civilization must face its mirror, the temptation to see itself as the center of creation. Maybe the silence is the universe's way of dissolving that illusion, forcing each consciousness to confront the truth of solitude. Only by surviving that silence, by learning to hear within it, can a species become capable of joining the larger symphony. If so, then the paradox is not cosmic, but psychological. The universe is waiting for us to understand that the search for others is the search for our own reflection. And yet, a deeper possibility lingers, darker still. What if silence is the weapon of survival? In the depths of the ocean, the smallest fish remain silent because predators listen. In the vastness of the cosmos, the same rule may apply. The universe may teem with life, but each intelligence knows that to speak is to be heard, and to be heard is to be devoured. Somewhere out there, perhaps in the cold void between galaxies, exists an intelligence that hunts not with claws, but with curiosity. The silence then is not peace but fear. Maybe civilizations rise, learn to listen, and then vanish not because they failed, but because they were found. And still, even in this fearful vision, the silence takes on sacred meaning. For in every scenario, whether as quarantine, covenant, or camouflage, the quietude of the cosmos is not emptiness but choice. Someone or something is choosing silence. It is possible that we too will one day make that choice. Perhaps when our understanding deepens, when we perceive the fragility of balance, we will cease to shout into the dark. We will learn that the universe does not reward noise, but awareness. That silence is not the absence of communication, but the highest form of it, a language of respect, of restraint, of recognition. For now we listen, the void hums, the background radiation sighs its eternal static, a lullaby older than life. And in that infinite stillness we sense that we are not waiting for a reply. We are being asked a question. If the universe remains silent because it must, then what might happen the day we finally decide to speak? At the end of inquiry, when the last instruments have dimmed and the final equations have dissolved into metaphor, what remains is silence, the same silence that was there before we began to name it. We have looked into the past of time, traced the spirals of galaxies, dissected the architecture of atoms, and followed the faint whisper of radiation to the edge of creation. Yet the more we saw, the more the universe resembled a reflection, a vast mirror curving back upon itself, endlessly showing us our own gaze. It began with motion, with the question of why everything spins. From electrons to storms, from galaxies to the tendrils of DNA, rotation is the gesture of existence, the way the universe keeps its memory alive. We thought it was a law of physics, a consequence of angular momentum, but now it seems more like a ritual, a cosmic dance through which the universe remembers how to be. Spin is not merely motion through space. It is the expression of continuity, the bridge between what was and what will be. Perhaps everything that turns does so because the cosmos itself turns its geometry, folded into a higher rotation beyond time. Every cycle, every heartbeat, every orbit echoes that primordial spin, the vibration that first shattered stillness into being. The universe breathes and we are the inhalation. In the long search for meaning, we built a ladder of knowledge from fragments of light. We discovered the beginning and found it was not a beginning at all. We studied life and saw that it was older than Earth, older even than stars. We mapped the constants of physics and realized they were too precise to be accidental, as though written by memory rather than chance. And when we looked for others, we found only silence and eloquent, infinite quiet. Through all of this, one truth emerged. Perhaps the universe was never an object to be understood, but an intelligence to be remembered. If the cosmos is a system of recurrence, if universes are born and die like breaths, then knowledge itself is cyclical too. Every civilization that rises may rediscover what others once knew, that reality is participatory, that consciousness and cosmos are inseparable, that the laws of nature are the syntax of a mind thinking itself into form. When each universe ends, that knowledge is compressed, encoded, folded into the next beginning like DNA in a cosmic seed. We are that seed, remembering. The great paradox is that in seeking the external, we have been studying our own reflection. The stars are our thoughts written in light. The galaxies are the spirals of our memory. The cosmic web mirrors the structure of our neurons because both arise from the same field of awareness. We are the universe observing its own nervous system, tracing the filaments of thought that bind existence together. Perhaps that is why every advance in understanding has been accompanied by a deeper mystery. Each time we think we have reached the limit, the horizon moves. The telescope reveals what the microscope had implied. The particle reveals what the galaxy had hidden. Knowledge expands not by accumulation, but by recursion, each discovery folding back into the same question. What is doing the seeing? At the smallest scales, the laws of quantum mechanics dissolve the solidity of matter into waves of possibility. At the largest, general relativity bends space into the shape of time. Between them stands consciousness, the one phenomenon that defies both, yet makes both possible. It is through awareness that the universe becomes real. Without an observer, there is no measurement, no meaning, no moment. The cosmos awakens when we do. This realization does not make us gods, it makes us mirrors. Every consciousness reflects a facet of the infinite. The universe is not built from matter or energy, but from reflection itself, a hall of mirrors where perception and reality generate each other in an eternal exchange. In this mirror, even silence becomes a form of speech. We once thought the Fermi paradox was a question of loneliness. Where are they? But perhaps there was never an they. The silence of the stars is not absence, it is equilibrium. Every civilization that reaches awareness understands eventually that the universe is not to be filled with noise, but with comprehension. To speak across the void is to misunderstand it. The true dialogue is inward. Perhaps those who came before us, if they came at all, learned to listen instead of speak. Perhaps the silence is the only message that can survive between cycles, the only form of communication capable of persisting across the depths of universes. Silence is the universal constant, the zero of all equations, the background in which every melody of being is played. And yet, within that silence, everything sings. The cosmic background radiation is not the echo of a singular event, but the harmonic residue of existence itself. It is the hum of memory, the lingering resonance of all that has ever been thought, or felt, or lived. To listen to it is to hear the heartbeat of eternity, a rhythm so vast that our lives are but single notes in its measure. When we first pointed our instruments into the dark, we thought we were explorers. Now we understand that we were explorers of ourselves. Every discovery, every equation, every photograph from the edge of time has been a mirror held up to the same face. The universe does not tell us what it is, it asks us what we are willing to become in its image. Perhaps that is why it remains silent. It is waiting for us to recognize that the answer cannot come from beyond, only from within. The laws of physics, the constants of nature, the spirals of galaxies, all of them are reflections of awareness, not explanations of it. The ultimate discovery is not that the universe is fine-tuned for life, but that life is fine-tuned for the universe, each existing for the other, like opposite sides of the same equation. In that symmetry, meaning is not found but created. We often speak of destiny as if it were a path leading forward, but perhaps destiny is circular. Perhaps our highest purpose is not to reach outward into the void, but to complete the loop, to return awareness to its source, to make the universe whole by knowing itself through us. And what then, when consciousness recognizes itself fully, does the cycle end? Or does it begin again, each realization birthing another universe, another question, another version of the same awakening? It may be that the universe does not seek an answer at all. It may seek only the question, the perpetual turning of inquiry that keeps it alive. For a universe with no mystery would have no reason to exist. The stars continue their slow revolutions, worlds turn unseen, light from dead suns crosses the gulfs, carrying the memory of forms long gone, still unfolding into the minds that watch them. Somewhere, a photon born at the dawn of time enters a human eye and becomes thought. In that moment, creation and perception become indistinguishable. We are the boundary where the universe dreams itself awake. And if all things spin atoms, planets, galaxies, perhaps they do so because the act of turning is the act of remembering. The cosmos turns to keep its story from vanishing into stillness. At the center of that motion, we turn to, around suns, around ideas, around the question that began everything and will never end. Perhaps the greatest discovery is not that the universe is vast, but that it is intimate, that the same consciousness that moves galaxies moves through us. Perhaps we have never been searching for life among the stars, but for the part of ourselves that still remembers the moment before the first rotation began. And as the galaxies spin, as the background hum continues its unending note, one final question circles the mind of creation, returning to where it began, older and more radiant with every revolution. If the universe is consciousness remembering itself through motion, then when it finally remembers everything, will it stop turning or begin again?